Hey everyone, this is Mr. Garcia, and this lesson you are going to learn how we use algebra and geometry. Okay, so you're going to learn why we're able to solve equations and the properties we use when solving equations. That has not been explained to you yet, but you will get it from your geometry course, and that will happen today. So please pay attention to the notes and copy the notes as I go over each example on the notes and as I give you each definition. Okay, let's get started. Okay, so this is 2-5 reasoning in algebra and geometry. Okay, so we are going to go over the properties of equality and congruence. So when we say equality, that means when you solve equations, you have the equal sign. And congruence, that's when you have, for example, one angle being congruent to another angle, or a segment congruent to another segment, which basically means the same. It means that the angles are equal or that the segments are equal. All right. So let's start with some basic assumption here, okay? So the basic assumption is that we have A, B, and C be any real number. Now, don't forget, real numbers are positives, negatives, fractions, or rationals, irrationals. All the numbers you can think of on the number line are real numbers, okay? And so let's start with the properties. So I'm going to show you each one of the properties so you can copy this on your notes. And at any moment, press pause on the video so you can copy all of this, okay? All right, so we have the addition property, okay? And that addition property says that if the number A is equal to number B, and we're adding, that means that I can take the number A, okay, and I can add a number C, which is what's mentioned here, and that is going to be equal to B plus C. In other words, in algebra, you saw that if you do something to one side of the equation, you also have to do it to the other. You can't just do it to one side, and that's because of this property. Okay, so if I'm adding something to A, I also have to add it to B so that this property is followed. Now the next one is a subtraction property. So this one says also that if A is equal to B, then I can take A and subtract a number C from it. And C, again, A and C and B can be any numbers you can think of, okay, any real numbers. So if I subtract C from A, I also have to do it from B, okay, because of this property. Okay, the next one is the multiplication property. So this one just says that if A is equal to B again, then if I multiply the number A by a number C, or real number C, then that is going to be equal to A times C. And I hope you're seeing this here. Whatever you do to one side, you have to do to the other. Okay. All right, the next one is the division property. And on this one here, there is something else we need to consider. Okay, consider that, well, A is equal to B, and notice this one here, C cannot be equal to 0. Why? Because division by 0 is undefined. So if you have a 0 on the denominator and a number on the numerator, you can't do that. It's undefined, okay? So that's why we have C cannot be equal to 0. But in any case, if I take A, okay, and I divide A by a number C, then I have to do it to B also. Okay, so B is going to be divided by C. And again, following that rule, that whatever I do to one side of the equation, I gotta do it to the other side. Okay, let's go on to the distributive property, and this one is one that you saw in Algebra 1, and you've seen it also before Algebra 1. So you just distribute the A to the B and to the C. So then this gives you A times B. So this is AB plus A times C. Okay, and if this is minus, if it's B minus C, it's still the same thing. Okay, that's the property, that's the distributive property. Let's go on to the substitution property. This one just says that if A is equal to B, then B can replace A at any moment, whenever you need it to replace A. So let me give you an example here. So notice I have A equals 2, so that means A is A and B is 2, okay? And then I'm going to give you an equation. So the equation is 4 times A minus 3. Since a is equal to b and a is 2, I can replace a with the value b, which is 2. So 4 times 2 minus 3. Okay, so I just wanted to show you that example. And this is why we use substitution in algebra. Once you solve an equation, you're asked to check your answer, which means you're going to use the substitution property to see if your answer is correct. Okay, now let's go to the reflexive property now. So we have 3 more properties to go over on this lesson. One is the reflexive property, and this one just says that if that a is equal to a. So this is like saying if I get up in the morning and I look at the mirror, okay, and I'm in front of the mirror, I should be able to see myself. If I see somebody else, then I better, take up running, because I should be able to see myself. So that's what the reflexive property says. A is equal to a. Symmetric property, this one says that if a is equal to b, then b is equal to a. So this one just switches, okay? So if a is equal to b, then this is the same thing. You can switch them and it's still going to mean the same thing. The next one, this one is if a is equal to b and b is equal to c, okay? And we did something similar to this yesterday in the classroom, or if you're online, you also saw this online. Then if a is equal to b and b is equal to c, then a is equal to c. And this is called the transitive property. And this is similar to, so I'll just add a note here, similar to the law of syllogism, okay, which was on the lesson from yesterday. So it's very similar. If P implies Q and Q implies R, then P implies R. And if you don't remember that, go back and look at your notes. That was covered in yesterday's lesson. Okay, that's all for this lesson. The next lesson, if you have any questions, I'm sorry, do let me know. If you're a face-to-face student, you can ask me questions in the classroom. Or if you're an online student, you can send me an email or a Canvas message or a remind message, and I'll reply to you. I'll reply as soon as I get a chance, okay? Thank you for watching. Bye-bye.